Hi, I'm Niam. Today we will talk about test-driven development. We as developers are familiar with testing or unit testing. Unit testing is a method to ensure individual units or components of the software are tested. The purpose is to validate that each unit of the software code performs as expected. Unit testing is done during the development or coding phase of an application by the developers. The workflow of unit testing is after we implement the code or feature. This sometimes tend to make developers think the same thing twice, which are when implementing the code and when writing unit tests. Also, if the implemented code is a complex feature, the developer will find it difficult to write test case and will miss some scenarios of a feature. So what if we reverse the workflow? Write the test case first and implement the code later. This comes with the approach of test-driven development. Test-driven development, or TDD, is a software development approach in which test cases are developed to specify and validate what the code will do. In simple terms, test cases for each functionality are created and tested first, and if the test fails, then the new code is written in order to pass the test and make the code simple and bug-free. TDD has three main stages: red, green, and refactor. These stages is like life cycle of TDD process. Red is to think about what you want to develop. As the code is implemented later, when we write a test case, it will fail. This is a red stage. In this stage, we should write the test that matches business requirement and ensure all scenarios are covered. Green is think about how to make your test pass. After we write a test that fails, then to make it pass, is it on the green stage, which is simply to make the test pass and we don't need to over-engineer the implementation. The goal is just to make the test pass or green with simple implementation. Refactor is to think about how to improve your existing implementation. You can begin thinking about how to implement your code better or more efficiently. Then when it needs improvement, we can refactor the code as long as it follows the requirement. All tests should be passed. When the requirement changes, we also need to improve the test case. We continue the loop to the red stage, where test case will fly again, and then make the implementation and refactor the code later. At the first time you trying to use TDD, you will find TDD is challenging, as you need to figure out what the behavior of the feature or implementation could be in your mind. Now I will give you an example implementation of test-driven development inside the code. Let's check it out.
For the TDD demonstration, you need to create a new file. First is for the test. Okay, for this one, I will demonstrate about simple calculator and the program itself. Okay, for the environment, I need to install first. Okay, let me run this. Install PyTest. So I am using PyTest here. It's simple and easy. Okay, I think it's less installed. Okay, we start from the test first. Import PyTest. Okay, and also the program. A simple calculator. Okay, we see the simple calculator is empty, no line at all, and we just need to implement the test first. Okay, test, for example, I will need to add addition. Okay, we expect the simple calculator program should return the correct addition result. Let's simple import with now and result. calc. Okay, 1 and 3 maybe. Okay, and we assert the result should be 4. Okay, let's try here. PyTest. Okay, the test failed because we haven't implemented the code, and this we call grad base. Okay, just need to implement the code with simple implementation. Okay, let's test, and yeah, test passed. Okay, let's add another case for the feature, for the addition feature. For example, we need to validate the input first. Okay, so we expect the test should throw an exception. Okay, for example, yes, just copy this and change the parameter to something like integer here. Okay, in PyTest we can assert or get the code block below that is throw an exception. We can use as exception info. We expect that this code block raise an exception. That's why we use this code block. And we need to assert the exception message. To get that, we can use zero function, case function, and value. Let's say input. Okay, here we expect that this code block should raise an exception with this message. Okay, let's run the test. Yes, it throws an exception, but the message is not what we want. Okay, can refactor this code, add logic here. If not, we just need to okay. I think should be okay. Let's try. Okay, that's fine. Okay, the second test case is fine, and we need to add more. We need to, or we want to add number at once. So we need to add more case here because it's plural, and but with more than one. Okay, and result should be 13. Okay, alright. Yes, okay. This one can put us again, and it's well because it just take two argument, and we need to refactor. In Python we can use like spread parameter, like we can just call it num. Okay, because we already have validation here, we just need to use this and make it only one. Okay, we need to define the result first. Started from 0, and we need to add when it's looping num. Okay, and we just need to return the result. Makes sense. Let's try again, and test space. Okay, that's pretty much simple, I think, for this test case. You just need to add one by one per test case and implement, add the test case again and implement again. So I can add some more feature here for simple calculator. Let's say we want to add subtraction function to number. Let's make a simple test case first, and res result calc 4 with 2. The result will be 2, and after we implement write the test, we need to run the test again because we haven't implemented the subtraction function. Okay, we can implement the app with just simple function, and we don't need to follow this because subtraction maybe have some different case inside because it's different feature. and we just need like for example like before on the addition stick num1 and num2, we just the simple implementation and run the test again. Okay, the space, and we can add more like this. Can just copy subtract number is valid, so we can example to should throw an exception. Okay, let's try again. Yeah, it's throw an exception, but the message is not what we expect. We can refactor again. Okay, use this, reuse this, and just make a simple implementation for this like before. num1 and num2. Wait. Okay, and test again. Okay, you test based, and we add more test case again, like on the addition stick, like for example test subtract numbers. Okay, for example sub, we have four number here, like 6 minus 3 minus 4 minus 2, for example. So be 3 minus 4 is minus 3. Okay, the result should be minus 3. Yeah. Okay, and okay, we have run refactors, and after you write the test case, you need to run the test first and let's see if it's working or not. Okay, just need to fix this one. Okay, let's refactor this. We need to refactor the parameter with nums, and yes, we reiterate through the nums. Num in nums, like okay, we can reuse this and change it to just only one condition. Okay, there is error. Okay, from this stage we for the subtraction we need to add or define the result value, because we need to save it when we add operation inside loop block. Okay, for example, okay, you can name it like none and just make a simple implementation with. Okay, let's try again. Oh no, it's break 2 tests or 3 tests. How can it be? Let's try again. We can assume that yes, we can rename this. Sorry. Then again, okay, just to test field, and we need to rethink again here. Okay. So the rest value is none. Okay, we need to reassign the value first. So let's check this. Let's say we can reassign the value to num this and try again. Make sure there is no non-type error and test. Okay, non-type error is gone, and we have another result or violet that I think it's the subsection function is not correct, the logic. Okay, we need to rethink here again. Alright, we can continue when it's none. So the assigned value should be subtracted by the next number. Okay, and run this again, and done. All tests based. Okay, this is an overview for the test driven development. So the development process is driven from the test. So we need to write the test first with along with the test case and scenarios, and run it one by one, edit one by one, and the implementation should follow the test. And yeah, that's all from the test driven development demonstration. Yeah, but the first time it's quite hard to try, because you need to more time to figure out how to implement code, and yeah, quite hard for at the first, but it will be very easy as you practice with TDD implementation. Okay, That's all from my side, and I hope you enjoy this demo.
In this section, you saw an example on how you can use TDD to improve confidence that your code is working as expected. You also saw how to use an existing text to keep you on track while you refactor implemented code. If you use red, green, and refactor TDD to approach large software implementation problems, you will find yourself saving time while implementing a more robust solution than you otherwise would have. Thank you for watching our video about this TDD or test-driven development discussion. I hope this content beneficial for you and see you on the next video. Thank you.